So we'll continue on with inverse functions. Today we're going to look at how to determine the equation of the inverse function. Okay, so for starters, you'll need to remember these four things. Okay, and there's a little catch with step 4. Replace y with f inverse x if the inverse is a function. So how do you tell that just by looking at these equations? Well, you should have some sense of what this curve actually looks like. F of x equals 3x plus 6. It is a linear function. It is a degree of 1. Linear means it would make a straight line, something like this. And if I did a horizontal line test on that, it would pass the horizontal line test. That means its inverse would be a function. Okay? With part B, this is a second degree function. It is a quadratic. It's going to make a parabola, which does not pass the horizontal line test. Means that I cannot replace y with f inverse x without restricting the domain on part B. All good in part A. I can do all 4 steps. In part B, I'd have to make a restriction on the domain before I could replace the y with f inverse x. We'll get to that in a minute. Okay, so for starters, part A, we'll look at this equation, f of x equals 3x plus 6. Step 1, replace f of x with y. Tricky stuff. Y equals 3x plus 6. Step 2, switch the x's and y's. So anywhere I see a y, I'm going to replace it with an x. And anywhere I see an x, I'm going to replace it with a y. Step 3, this is kind of where the work comes in. You've got to solve for y. So in order to solve for y, that means get y by itself. So how would I get rid of the plus 6? I'd drag it across the equal sign, change its sign when it goes over, so I'd have an x minus 6 over here. Or you can subtract 6 from both sides. Either way, you're going to get x minus 6 equals 3y. Now, I don't care that it says 3y, I just want it to say 1y. So how do I get rid of a times 3? Well, I would divide by 3. That would leave a y here, so I'll divide by 3 on this side and divide by 3 on this side. And there we have it, y equals x minus 6 divided by 3. And remember, since this did pass the horizontal line test, okay, it's okay to write it like this. Now I can do step 4. Step 4 is replace the y with f inverse x. And there it is. There are some other ways that you may see this, okay? But this is perfectly fine right here. Okay, you may see it written like this as well. X over 3 minus 2, like x divided by 3, 6 divided by 3 would be 2. Or you could see f inverse x equals 1/3 x minus 2, same thing. But just keep in mind, okay, that one equation undoes the other. So like let's try f of x equals 3x plus 6. What would I get if I filled a 1 in for x? F1 is going to equal 3 plus 6, 9. Okay? That means that if I plug a 9 into this equation, I should get a 1 for an answer. So 9 minus 6 over 3, f inverse 9 is going to equal 3 over 3, which is 1. So the point 9 comma 1 is on the inverse, and 1 comma 9 is on the function. Here's a picture of what they look like. Okay, there's y equals 3x plus 6. There's y equals x minus 6 over 3. And again, you can use the following notation. F of x equals 3x plus 6. That is a function. And you can use F inverse x equals x minus 6 over 3. It's also a function. It's the inverse of this blue. Okay? Now, when it comes to this one, as we said, this is a parabola. Okay? It does not pass the horizontal line test. So I cannot do step 4 without restricting the domain. Okay? So I can do step 1, 2, and 3, no problem. Step 1, replace the f of x with a y. Step 2, switch the x's and y's. So everywhere you see a y, write an x. Everywhere you see an x, write a y. Step 3 is to get y by itself. So I'll add 4 to both sides. So I'll have x plus 4 equals y squared. Okay, and then to get rid of this degree 2, I'd have to take the square root of both sides. So y is going to equal the square root of x plus 4. Now keep in mind, that could be a positive or a negative. And there we have it. Y equals the positive or negative square root of x plus 4. That is the inverse. It's not a function, remember, so I cannot replace that with f inverse x unless in order to replace this with f inverse x, like so, I would have to restrict the domain. So this is true if I do the following. Keep in mind the vertex of this. Remember from grade 11, this is kind of pre-cal 11 stuff. The vertex would be at 0, negative 4. That means the axis of symmetry, so this is also going back to our last video, would be at x equals 0. That means your restriction on the domain, if we want to cut that graph in half so that it would pass the horizontal line test, could be either x is greater than or equal to 0 or x is less than or equal to 0. I will choose this one. Okay? And what that does is it would use the positive square root of x plus 4. If I chose this one, so I'll just write this little restriction afterwards, and now I can do the following. Okay? That answers this question right here. Notice the picture, all right? There is the curve y equals x squared minus 4, the parabola. You can see the vertex here better, okay? There's the vertex at 0, negative 4. There it is, written as an inverse, not as a function. If I wanted to replace y with f inverse x, I'd have to restrict the domain like I did here. One more example of that, just so you don't think they're always x is greater than or equal to 0. Check this one out. You can see the axis of symmetry, or the vertex, is at 1, negative 2. The axis of symmetry would be at 1. That means the restriction, if I want to make sure that the inverse is a function, the restriction would have to be x such that x is greater than or equal to 1, or x such that x is less than or equal to 1. And here you can see it. Okay, and that makes this inverse. Notice they replaced the f of x with f inverse x. Now, you can continue working on the following problems from the textbook. If you have any questions, post them in the Teams app, and we will correct them there. And that is the end of Chapter 1.